Solve the bonus for the Kinematics Review worksheet. This is the one where you have two cubic cannonballs and they're going to collide in midair. The one is set at 75 degrees and the velocity coming out is 9 meters per second. We also know the cannons are 6 meters apart. All we know is that the two humans are going to collide 1 meter above the cannons. So we don't know if they're going to hit on the way up or on the way down. Further, we don't know, is it on the way up for one of them and on the way down for the other? Or is it on the way up for both of them, on the way down for both of them? Lots of things we don't know here. So, but we know a lot about this first one here. We know that it's going to collide 1 meter above. So that's going to help us find a couple times. So let's look at the vertical distance for that one that we know. I'll call this cannon 1, this cannon 2 over here. So I know that d equals VIT plus 1/2 AT squared. So this would be the initial velocity, which is 9 meters per second, times the sine of 75 degrees. That's the vertical VI part, times t, the time I don't know, plus 1/2 of the acceleration of -10 meters per second squared, times t squared. And I actually know this distance. It's 1 meter. So this is 1 meter. And I can solve this for time, this quadratic, and I get two values for the time. I either get 0.12385 seconds, or I get 1.6148 seconds. Those are the two zeros for that equation at this height of 1 meter. So there's two possibilities. Either it's going to hit here or it's going to hit here. I don't know. One of the two. Okay, so what would the other vertical equation be? Well, for that one, it's still going to be 1 meter equals, I don't know the velocity coming up there, so I'll call it v. I don't even know the angle, so I'll call it sine of theta times the time, one of those two times, plus 1/2 of -10 meters per second squared times t squared. Well, I could go ahead and plug in both of these two times. And I could solve for what v sine of theta is. And when I do that, v sine of theta would be equal to either at the time of the 0.12385 seconds, either let's see, 8.6935 meters per second, or at the time of 1.6148 seconds, v sine theta is equal to 8.6933 meters per second. Okay, well, let's see. That doesn't really help me a whole lot. Both of those values are pretty much the same, and so I'm not going to be able to figure out what v is or the angle. So now let's look at the horizontal components. I know that this one is going to travel a certain distance. Let's say it hits right here. That distance would be delta x1. The other one then is going to have to travel the other distance. I'll call it delta x2. Both of those have to add up to 6 meters. Regardless if it's there. Maybe it's over here. So delta x1 plus delta x2 still has to be equal to 6 meters. So let me put this in here. Delta x1 plus delta x2 equals 6 meters. Well, that's constant velocity motion. So for the one, I could just simply go 9 meters per second times the cosine of 75 degrees times the time plus v cosine of that unknown angle times the time equals 6 meters. And from that equation, I could figure out what v cosine of theta is, plugging in again these two times. At 0.12385 seconds, I get v cosine of theta to be equal to 46.116 meters per second. And at the other possible time of 1.614, when I plug that in here and solve for v cosine theta, I get 1.38626 meters per second. So look at those two there very carefully, because that's all the information I need to solve this. Because now I could take the top equation and divide it by the bottom equation. Same thing over here. And when I do that, the v's will cancel. Sine of theta divided by cosine of theta is tangent of theta. So tangent of theta will be equal to 8.6935 divided by 46.116 meters per second. Or tangent of theta is equal to 8.6933 meters per second divided by 1.38626 meters per second. It's one of those two. And when I solve this for theta, I end up getting an angle of 10.675 degrees. Well, it tells me that it's greater than 45 degrees. So I know that that one's not it. So it's not that time there, it must be that time. And so when I solve this one for theta, I get an angle of 80.94 degrees. And that's good, that works. Now I can plug that angle in pretty much anywhere I want to. Either I could put it in right here, or I put it in right here and solve for v. So let's do that. V times sine of 80.94 is going to be equal to 8.6933. Solve for v, and I get v to be equal to 8.8 meters per second. So the velocity is 8.8 meters per second, 80.94 degrees above the horizontal.